Hey everyone, welcome back to my channel. This is Rahul. Today we are solving one lead code problem, find eventual safe states. This is a medium level graph problem and we will solve it using reverse topological sorting. I will explain the problem, the algorithm we used and how to code it. So let's get started. So here we have one directed graph with n nodes labeled from 0 to n minus 1. Each node has a list of outgoing edges represented as a 2D graph array. A terminal node is a node with no outgoing edges. A safe node is one where every path starting from it eventually ends at a terminal node or another safe node. So our task is to find all the safe nodes and return them in ascending order. So let me briefly explain the algorithm we are using. Here a node is safe if all paths starting from it leads to terminal nodes. To simplify this, we reverse the graph and process the nodes that have zero incoming edges in reverse graph. So we will follow some steps for this. First of all, reverse the graph so that edges point back to the source node. Then we have to track the integrity of each node, means the number of edges pointing to it. After that, we have to use a queue to process nodes with zero integrity, which correspond to terminal or safe nodes. Then we have to keep reducing the integrity of neighboring nodes and add them to the queue once the integrity becomes zero. At the end, we will have a list of all safe nodes. So let's dive into the coding part. First of all, we will start with one abstract list. So I have to import that here, java dot util abstract list, and I will just create one list named safe node, integer safe nodes. Now I will initialize that we will use the abstract list for lazy initialization. So return new abstract list integer. So here we will use the get and size method. Ensure that the safe node is computed only when it needed. So I will use the override annotation, public integer get int index. Init method, we will write the code later for init from safe nodes dot get index. Then again come out of the loop and write one force to get the size. Override public int size. Same, we have to initialize the add the init method, return safe nodes dot size. So by using this, we will only use when it necessary, and we will start our section now. So here you can see it's a 2D graph, means 2D array, and we will start with our initialization, means lazy initialization with init method, private. We will use void for that, init. So this init method ensures we compute safe nodes only once. If safe node uh, is already computed, we simply return. Then we have to initialize the graph data structure. So for that, I have to get the length of graph length. Then I will use one variable to represent the reverse graph. Just integer reverse h, which will be a array list. Then I will store the eventual safe nodes in safe node. Safe nodes equal to new array list. Then I will use one variable in order to store track the number of incoming edges for each node. For that, I am using the name in degree. So for int I equal to 0, I less than n, increment I, we will add the new array list to the reverse we created. Add array list. Now we will build the reverse graph. So first we have to come out of the loop. For int I equal to 0, I less than n, increment I. Then we have to check every index. So every edge in the original graph. So we add uh, neighbor node in the reverse graph. For that we will use the each for each loop, neighbor node, f of I, reverse hatch. We will use the get method, neighbor node dot. Then simultaneously we have to update the integrity of each node. So we just increment it. Same, we have to come out of the loop now. Then we have to identify terminal nodes. For that we will use q integer new linked list. So we have to iterate through the array. And nodes with the zero incoming edges in the reversed graph are terminal nodes. So we have to check that if integrity of I is 0, then we have to add them to the queue for processing. Queue dot offer I. Then same, we have to come out of the loop now. Then we need to process the queue. Means we have to process each node in the queue, marking it as safe. So I am using while loop, while queue is not empty, int safe node queue, sorry, queue dot all. Then we have to add the we have to mark it as safe node. So I will add in safe nodes. We already initialized it. Add safe node. Then we have to check for every neighbor of the current node. We have to reduce its integrity. For that, I am using the for each loop. Neighbor reverse hatch dot try to get the safe node. Then we have to um, decrement integrity. Neighbor decrement it simply. Then we have to check if neighbor's integrity becomes 0. Then we have to add it to the queue since it's now safe. So we will check now if integrity of neighbor is 0. Then we have to add it to the queue. Now queue dot offer neighbor. Now we have to come out of the loop. Then we have to sort the safe nodes. So I will use collections dot sort safe nodes, which will sort the safe nodes list in ascending order as required by the problem. Let's run it. Okay. Oh, anything more? Here it is 9:30. 32 degree. Hmm. Okay, I forgot to add the index. Now let's run it. Yeah, it's working. So some spelling mistake was there. Sorry for that. And it's working fine. Let's submit it. Yeah, it's beats 100% with the 0 ms of time, which is the most efficient way we can write this code with less complexity. So when it comes to complexity, we have three things here. So in time complexity, first of all, revising the graph, it took big of v plus e. That is, v is the number of nodes and e is the number of edges. Second, topological sorting, same big of v plus e. Then sorting takes big of v log v. So total complexity is big of v plus e plus v log v. And that's how you have to solve find eventual safe states using reverse topological sorting. I hope this explanation make things clear. If you found this video helpful, don't forget to like this video, subscribe to the channel and hit the bell icon for notifications. If you have any question, drop them in comments below and I will help them. Thanks for watching and I will see you in the next video. Bye.